If you like movies like Everything, Everywhere, All at Once, Spider-Man No Way Home, Spider-Man Into the Spider-Verse, and Doctor Strange Multiverse of Madness, then you might also be interested in the concept of a multiverse. The multiverse might actually be more plausible than we might expect. In this video, I'm going to discuss some of the theories and concepts that make the multiverse more real to us than these movies. Let's start from the beginning, the very beginning. In the beginning, the universe began as a super hot and infinitely dense singularity. From the explosion of this singularity came the forces of nature and elementary particles, and from those elementary particles came all of life and matter as we know it. Here is our universe, our beginning and expansion of time, and it's headed in this direction. That's also asymmetrical. According to the law of thermodynamics, i.e. entropy, time can only travel in one direction. In other words, you can't put an egg back together after. However, black holes have a lot in common with the early universe. They are both infinitely dense and both a singularity. When primordial black holes evaporate, it is predicted that they emit all particles. Now, what happens when you get too close to a black hole? You get sucked in by its gravitational forces, and you'd have to travel faster than the speed of light to escape. All matter in its way will get pulled in. Where does it all go? Max Tegmark proposed 4 levels of the multiverse. In level 1, we have a twin somewhere out there in an alternate universe, a copy of ourselves. In level 2, we have many copies of ourselves, and they all live life by the same laws of physics that we do, but they have different equations based off their bubble's initial conditions. In level 3, all the possibilities of ourselves are out there, and all outcomes of all decisions ever needed to be made. Every conceivable possibility is its own bubble. The level 3 multiverse is a lot like the undefined portions of the Mandelbrot set, where chaotic inflation transforms the universe into a huge, eternally growing fractal. Mandelbrot sets are a lot like black holes too. Like the singularity of a black hole, the area of a Mandelbrot set that appears to be black is considered unbounded or undefined. So when we're going through a black hole, perhaps we're entering a space like here in the Mandelbrot set, and when we come out, perhaps we're in one of those fractals, which would be labeled a level 3 multiverse. Lastly, in level 4, all the possibilities are there, as well as all the mathematical structures discovered. Any mathematical structure, even those that our universe cannot test, is real and exists in an alternate universe. So when we go through a black hole, are we entering a parallel universe where our twin might be? Perhaps we experience universes where we can fly or bounce really high with little effort. Or maybe we travel through bubble after bubble and see all the possibilities of ourselves that could ever exist. Could it be possible that we enter spaces of the multiverse that are void of any life, thanks to their mathematical structures? Maybe going through a black hole would allow us to traverse the multiverse and travel back in time in our own universe. Closed time-like loops are mathematically possible, though the process is not an observable one. To illustrate the concept of closed time-like loops, let's look at light cones. Light cones tell us which direction the path of light is headed, which is towards the future. In some coordinate systems, light cones have the ability to tilt and follow a curved path of space-time. Since the center of every black hole is infinitely curved, this would allow our light cone to curve, and perhaps this would loop us back into the past. Thanks to decoherence, we might never truly know, but it's fun to imagine ourselves as superheroes traversing the multiverse.